Greetings everyone, today we're going to explore square roots. First, let's talk about the definition of a square root. Now, if you're in class, you should have a note sheet. If you are not, you can definitely write these notes on your own notebook paper. Remember, where there's a pencil, we need to write it down. The definition of a square root is it is a number that when multiplied by itself is equal to the given number. So it seems silly. If needed, pause the video and write this down. But let me clarify with this example that's written here. A number that's multiplied by itself. So like a 4 squared would be a 4 times 4. That equals 16. So it's almost like we're going backwards, right? Is there a number times itself that gets me to 16? Yes, 4. If there's not a number, then we can have a decimal value. And in this class, we're going to avoid those. We're going to call those irrational numbers, and we're not going to use them very often, okay? But we are going to work on perfect squares, meaning when they work out nice and clean. Let's talk about the pieces of a radical. So the little check mark symbol is called the radical symbol. Whatever's underneath it is called the radicand. That's going to probably be a new word for you. The radicand can be a letter, a number, an expression. It could be a lot of different things. We're going to stick with just integers. A helpful tool is the multiplication chart because if you look at that diagonal, those are all perfect square roots because 4 times 4 is 16. So that means the square root of 16 is 4. Or even bigger numbers. The square root of 196 is 14 because 14 times 14 is 196. So let's get that down in our notes as well. Those nice clean numbers are called perfect squares. A perfect square is a number made by squaring a whole number. Take a minute to write that down. So what we're talking about here is 5 squared. It's 25. That means if I square root 25, I'm back to 5. That's a perfect square number, 25. What if I do 7 squared? That'd be 49. 49 is a perfect square because if I square root it, I'm back to 7. Let's practice. We're going to circle the numbers that are perfect squares, meaning a number times itself gets me there. So let's start with 1. 1 times 1 is 1. So that's good. Yes, that is a perfect square. Is there a number times itself that gets me to 12? 3 times 3 is 9. 4 times 4? No, not good. 16, is there a number times itself that gets me to 16? Yeah, 4 times 4, that's good. How about 20? No, that doesn't work out, right? How about 100? Yeah, 10 times 10 is 100, that's good. How about 121? Yep, 11 times 11 works, so that's good. How about 200? No, that doesn't work. Now 289, that's a larger number, right? So if you've got your times table, use that. But you could also use your calculator, you guys. If you plug this in and you get a nice pretty number, then that's good. So I want you to try that one on your own. And remember, if you're looking for the key on your calculator, it might look like this. Or some of you, we've taken a look in class and it was above the squared button, right? You had to do the second key first. So mess around with it. You could also, there's lots of calculators online you could use as well. All right, so let's break some of these down. The simplest form of square root of 64. So is that a perfect square? Is there a number times itself that gets me to 64? Yeah, 8. So my answer is 8. How about 25? What number times itself gets me to 25? A 5. Oops, but what am I missing here? Notice what's out front. There's a negative, so just keep the negative there. If there's a symbol, bring it down and include it with your answer. Ooh, now we have 2 of them. Okay, so we've got a big fraction bar. Let's start with that. On the top, square root of 121. Is there a number times itself that gets me to 121? Yeah, 11. Square root of 121 is 11. Okay, let's look at the bottom. Square root of 4. What number times itself gets me to 4? 2. So I have a fraction of 11 over 2. Oh, interesting. Look at this one. We have a radicand that involves multiplying. So let's take care of that radicand first. What is 2 times 8? 16. All right. And the radical symbol is still there. We didn't do that yet. Now, what number times itself gets me to 16? 4. Now notice when the number becomes smaller, there's no more radical symbol. We found the square root. It's just 4. Oh, wow. Let's try this one. Okay. Now, these extra numbers and symbols, I'm just going to rewrite them. Now let's deal with the new stuff. Square root of 25. What number times itself is 25? 5. Well, that looks weird, though. Doesn't that look like a 25 that I have written there? So what does it mean when 2 values are next to each other like this? That means we're going to multiply them, right? When things are next to each other, it means multiply. So I'm going to put a dot in there. All right, let's take a look at square root of 100. What number times itself is 100? 10. Oh, but that looks weird, right? When things are next to each other, that means multiply. Hey, look, now we're going to backtrack, right? Now we've got a situation where we need to use PEMDAS to simplify. No parentheses, no exponents. We need to multiply. 2 times 5 is 10. 4 times 10 is 40. The plus sign falls down. Next, adding and subtracting, we get a nice clean 50. Remember, if you need help with simplifying expressions, see our previous videos. As always, make sure that you check out Google Classroom to know what you need to do. If you have questions, let me know. Make sure that you seek out the Sabre Center if you need some help during your white space. Remember, that's in B202. And until next time, have a good one.